Thank you very much for being here. And first, before starting with this session, let's do a little poll, I would say. So how many people knows about Kafka? It seems all the people here. And how many people know about Strimzi? OK, less people about Strimzi. So for people who don't know about Strimzi, just a Strimzi 101, Strimzi is a CNCF incubating project about running Apache Kafka on Kubernetes. So you can use Strimzi, so all the operators that Strimzi provides for managing your Kafka cluster, to deploy your Kafka cluster, so handling the day one operations and also day two operations like setting up security or changing configuration or upgrading your Kafka cluster and so on. Now, for people who knows about Strimzi already, this session is not going to cover Strimzi itself, so the cluster operator, the topic operator, the user operator, the main core component within Strimzi, but more the ecosystem that we have around Strimzi. Strimzi is not just these operators, but there are several components within the Strimzi organization. And we will see how all these components can help you in order to kind of complete your solution. So the solution that you have by running Apache Kafka on Kubernetes. OK, so the components that, sorry. First of all, let me introduce myself. I am Paolo. I am an engineer working at IBM on the data and event streaming processing stuff, so mostly working on Kafka and Kubernetes and Strimzi, of course. I'm one of the core Strimzi maintainers. And I am also CNCF ambassador. But yeah, one of the most important things for me is to be fan of Formula 1 and MotoGP, so Ferrari. And with me, we have Michael.
Hello, yeah, my name is Michael Morris. I work for Ericsson Software Technology, which is a part of Ericsson that focuses on contributing to open source projects that are important to us. So as part of that work, I contribute to a number of open source projects in CNCF and elsewhere. And one of those projects is Strimzi.
So as I already mentioned, Kafka is not just the operator. You can see in this light azure block the Strimzi operator, so the core component that you have in Strimzi. But these are all the other components that we are going to show during this session. Let me just thank, first of all the contributors, because a good part of these components are coming from contributors in the community, even from mentorship for students, and then these components grow up and became the components that are today. So we will start in a kind of way that, let's say, we have an Apache Kafka cluster. Let's see how we can complete the solution of our Apache Kafka cluster by putting all these components, what kind of problems they are solving, so what problems you have and what kind of solution you have with these Strimzi components. So this is from where we are starting. We have the Strimzi operators. You know, the Strimzi operators, like as I already mentioned, the cluster operator, the topic, and the user operator are used for your cluster management. So you are able to deploy your Apache Kafka cluster on Kubernetes by using Strimzi custom resources, your Kafka custom resource, where you describe everything about your Kafka cluster. You can even handle the topics and users by using Kafka topic and Kafka user custom resource and so on. Within Strimzi, we have other components like Kafka Connect, Kafka Mirror Maker, so the support for all the Kafka ecosystems. And on the other side, of course, we have the clients, the Kafka clients, which are using your Kafka cluster, exchanging data, events, and so on. At this point, starting from here, let's see how we can add all the components that are part of the Strimzi ecosystem, as I say, to complete this solution and solving several problems. And with this, I hand over to Michael.
OK, so the first components that we're going to discuss in this session then are related to getting connected to the cluster. So you have an application that you'd like to communicate to the Kafka cluster with. Maybe you want to send some messages on a topic. Maybe you want to consume from the topic, or do whatever it is you'd like to do. So you can use a Kafka client that will take care of communicating to the Kafka cluster for you. But this client needs to be configured with cluster connection information, so as you can find the cluster, authenticate with the cluster, and so on. So you need to gather together all of this connection information in order to be able to get your Kafka client up and running. Or perhaps maybe have a use case that using Kafka client is not a particularly good fit. So maybe you'd rather use HTTP to communicate with the Kafka cluster, or perhaps you have an IoT device, in which case you might want to use MQTT to send data to the cluster. So the good news is Strimzi has a number of components that will help with these scenarios. So we have the access operator. So the access operator helps with configuring your Kafka client by creating a secret containing all the connection details that you need to get your client up and running. We also have the HTTP bridge then, which exposes REST endpoints that you can use to communicate with the Kafka cluster via HTTP. And we have the MQTT bridge then as well that your IoT devices can use to publish to Kafka via the MQTT protocol. So we'll discuss these components in a moment, but just before we do, we'll just have a look back again at the picture that Paolo showed us moments ago with our Kafka cluster as deployed by Strimzi. So now we'll add in here to this picture the components we're going to discuss in this section and start to build up this picture of what the overall ecosystem looks like. Okay, so now we have our HTTP bridge and MQTT bridge added in here at the top of the picture. So both of these are acting as bridges into the Kafka cluster itself. And down the bottom right-hand corner, then we have our access operator along with the secret that it creates that can be used then by the Kafka clients to connect to the Kafka cluster. Okay, so the first component we're going to talk about then is the access operator. So the purpose of the access operator is to simplify the sharing of your Kafka cluster connection information with your application. It's called an operator, fairly obviously, because it's a Kubernetes operator. So in order to make use of it, you have to create a custom resource. So the custom resource we create here is called Kafka Access. And in your Kafka Access resource, then you specify the cluster you want to connect to and the user you want to connect as. So the access operator will then go and read the connection information that you need to establish your connection from the various Kubernetes resources. And it'll create a single secret then that encapsulates all the connection information that you need. So your application can then use this secret as a single source then for the connection information that it needs to establish the connection to the Kafka cluster, instead of having to go and get bits of data from different resources. So using the access operator then simplifies configuring your client to connect to your Kafka cluster. So moving on then to the HTTP bridge. The HTTP bridge exposes REST endpoints that you can use to connect to the Kafka cluster via HTTP. It supports endpoints for producing and consuming messages, and it supports endpoint then as well for some administrative topics as well, such as creating a topic. So when the HTTP bridge then receives a HTTP request, it'll map that then into the corresponding calls in the Kafka native protocol using the Kafka client, and it'll send those off then to your cluster and handle the responses coming back. For observability then, the HTTP bridge supports open telemetry tracing, so this allows you to wire together the incoming HTTP request with the Kafka requests that are sent to the brokers and handle the responses coming back. It also supports exporting metrics in Prometheus format, so it comes with good support for observability built in. The MQTT bridge then, as the name suggests, provides an interface for accessing the cluster via MQTT protocol. This will typically be used then where you have an IoT device that's sending messages onto an MQTT topic, and you want to map those onto a Kafka topic. So in order for this mapping to work, you have to define how that mapping should take place. In order to do this, then you specify mapping rules. And you can see here in the slide we have an example of a mapping rule. So you can see that in the mapping rule we support use of regex, including regex grouping. So you can see here we've defined the topic, the MQTT topic, as building / and then a word, and you can see which represents the building name. And you can see this is surrounding in brackets, indicating that this is a grouping. Then we have /room, and then we have a number with 1 to 4 digits in it, which represents the room number. And again, this is surrounded in brackets, so this is indicating this is our second grouping here in our regex. So when the bridge receives a message then on a topic that matches this regex, it will then forward that onto a Kafka topic. And we've defined here in the mapping rule what the name the Kafka topic would be, which we got building _ $1. So the $1 represents the first grouping in our regex expression, which was the building name. And when it forwards on the message onto the Kafka topic, then you can apply a key. And we've defined here that the key should be room_$2. So that's room underscore with the second grouping from our regex, which was the room number. So if a message is received, for example, on MQTT topic, building/building B/room/101, then it'll be forwarded onto the Kafka topic, building_building B, and the Kafka key that'll be applied to the message will be room_101. Okay, so that's the components that we have relating to connecting to the Kafka cluster. I'll hand back now to Paolo.
So we have kind of fixed the first problem. So having all the clients connected, HTTP client, MQTT clients, but even simplifying how the Kafka clients are configured in order to connect to the Kafka cluster. Now let's talk about securing and governing access. So let's say that the security team want to know what are the clients that are using the Apache Kafka cluster, and they want to use a token-based authentication system, like for using protocol like OAuth. And on the other side, the other thing that we want to do is kind of avoiding noisy neighbors. So we want to start even throttling the clients in order to avoid that some clients are using too much the cluster and they are becoming noisy neighbors for other clients and so on. So starting from what we were with Michael, we are going to add two more components in the picture, which are the OAuth library and the quotas plugin, the Kafka quota plus plugin. So the OAuth library, as you can see here, is placed in the Kafka cluster, and even on the Kafka clients and on the HTTP bridge, because the HTTP bridge, as explained by Michael, it will act anyway as a Kafka client in order to send a message from HTTP to the Kafka cluster. And then, of course, the quotas plugin, which is about throttling clients running against the Kafka cluster and using the cluster for exchanging messages. So let's give more details. Regarding the OAuth library, the OAuth library provides two main components. As we saw in the picture, there is one component on the client side, because on the client side, you need to connect to the authorization service and then getting the token, the access token, by providing your credentials, and then you are going to use this token in order to be authenticate to the Kafka cluster. And on the other side, you have the server-side component for doing the token validation. In terms of token validation, it's really flexible. So first of all, the OAuth library is going to leverage the kind of framework that Kafka set up for you, so extending the callback for implementing the client to get the token or the server to run the validation of the token and so on. And it's using the SaaS OAuth bearer mechanism in order to exchange the token between the client and the broker. So this is something that Kafka provides for you. But it also adds this OAuth over plane that we will see in a few. And as I said, there are flexible ways to do the validation, as we'll see in the next slide. And the other thing that the Strimzi OAuth plugin provides is a token-based authorization using a keycloak authorization service. So it means that you can specify rules, permission on keycloak, so this client can do this kind of action on this topic, etc. And when you are using the plugin, it's get the token, it's get the information from keycloak, and then it will allow the client to run that operations or not, like the ACLs that you have today in Kafka, right? So regarding the validation, as I said, when you are using the SaaS OAuth bearer mechanism, there are two kinds of validation. The first one is the faster one is the local JWT token validation, which is happening locally on the broker. So it means that the client gets the token from the authorization server, and then it's forwarding the token to the broker, and the broker will use the validation by using public keys from the authorization servers in order to verify the sign of the JWT token, which is a JSON-based token, which is something that even Kafka provides out of the box in the last versions. But the Strimzi OAuth plugin also provides a kind of remote validation by using introspection endpoint. So it means that the token is got from the authorization server, is provided to the broker, and then the broker is providing the token to the server in order to get the token to be validated through the introspection endpoint. The most important part of it is that you can not just use JWT token, but also OPEC token that can be strings or anything that makes any sense for you. The other addition is the OAuth over plane, where the connection between the Kafka client and the Kafka broker will go through plane. So the client is going to provide credentials like a client ID and a secret, and then the broker will connect to the authorization server in order to get the token from that server, and then starting the validation. So locally or remotely, it depends. And as we see, there are the two options that we can use with the Strimzi OAuth plugin library. So that's the first issue that we have solved in this section about securing. The second one I mentioned about the Kafka quotas plugin. So in Kafka, there is already a way in order to set quotas. And it's a kind of way where you are assigning the quotas statically for your clients, as we'll see, while this plugin is going more in a dynamic direction. So you can assign statically the quotas per broker, but then these quotas is distributed across the clients dynamically. Also, the plugin provides some monitoring information like metrics about the throttling, about even the cluster-wide volume and storage usage that you have across the cluster. So you know about how many space still you have on the brokers themselves. When I was talking about the difference between the quotas that you have with Kafka, built in Kafka, and what you have with this quotas plugin, the main difference, as I said, is that in Kafka, you are assigning these quotas statically. So for example, you can assign the quotas in terms of bandwidth or the request rates in terms of percentage of usage of the CPU for the network and the out-thread. And for example, you can assign per user, per client ID, or even for both, a combination of both, and saying, in this example, that this client can use 10 megabytes per second as bandwidth, which is the max that it's going to have. While by using the Strimzi quotas, we are assigning a kind of static quotas for the broker, as you can see here, 40 megabytes per second, and then it depends on the client. So the throttling happens dynamically. For example, in this case, we are having one client using up to 10, the other one up to 30. But as soon as another client is joining the cluster, they will be throttled differently. So in a dynamic way, you can see here 30.3 megabytes per second, and one of them is throttled from 30. So it's totally different from how the Kafka quotas plugin works today. So this is an addition that this kind of plugin provides you in terms of handling the quotas. And with that, let's move to operations and reliability.
OK, next we'll discuss operations and reliability. OK, so the problems we're trying to address here are how do you drain your nodes, for example, for scheduled maintenance, or how do you make configuration changes in a way that minimizes the impacts on the operation of your cluster. So the tools we have to bring to bear here are the drain cleaner. So the drain cleaner provides a way to safely manage the eviction of your Kafka brokers during the node draining process. And we have the Kubernetes Config Provider then, which provides a way for doing a bit more advanced configuration of your Kafka components. So here's our picture again that we're trying to build up of the overall ecosystem, and we'll add in now the components that we're going to describe in this section. Okay, so we have the drain cleaner here on the right, interacting with the Strimzi CRs and with the pod eviction. It'll become clearer what's happening there when we discuss it further in the next slide. And we also have the Kube Config Provider in our Kafka cluster there. Okay, so moving on to discuss the drain cleaner then. So you could just let Kubernetes handle the eviction of your Kafka pods during node draining, but Kubernetes doesn't know or care about the replication of your topics. So using this approach could result in the number of replicas in sync falling below the minimum that you specified. So this is going to cause problems for your producers and your consumers. Using the drain cleaner instead helps ensure that this doesn't happen. So the drain cleaner uses the admission control feature of Kubernetes. This allows you to provide a hook that can be invoked when a request is made to the Kubernetes API server. And in this case, the hook is configured to react on a request to evict your Kafka pods. So what the drain cleaner will do then in that scenario is it'll deny the request. So this prevents Kubernetes from evicting your Kafka pods. And it will instead then add an annotation to the pods that will indicate to the cluster operator that the pods should be rolled. So in the next reconciliation loop, then the cluster operator will detect the presence of this annotation, and it'll roll the pods. Now, as the nodes that are being drained have been cordoned off, the pods won't come back up on the nodes that have been drained and be moved off to other nodes that are available. But, and I guess this is the key point here, when the cluster operator is handling the annotation, it will only roll the pods after checking that it's safe to do so, that the number of replicas in sync won't fall below the minimum that you specified. So in this way, the drain cleaner helps to protect the operation of your topics during the node draining process. Okay, so moving on to the Kubernetes Config Provider then. So you configure your Kafka components by setting properties. Now you could just set them directly to values, or Kafka also provides a mechanism called Config Provider that you can provide to Kafka to fetch values for your configuration properties from some external source. And that's what we've implemented here with the Kubernetes Config Provider. So this is a config provider that can be used to fetch values from your Kubernetes secrets or your Kubernetes config maps. So in the implementation here, we have a Kubernetes client that goes to the Kubernetes server API to fetch the values that you want to set your properties to. Now, the fact that this goes through the APIs means you don't have to worry about mounting the secrets or config maps onto your pods. But it also means as well that you don't need to worry about the secrets being in different namespaces or whatever, because you're going through the API. You can read them from whatever namespace you want. But it also means as well that the component doesn't necessarily have to be running in the cluster either. So you could have a producer that's outside of your cluster, and so long as it has access to the Kubernetes server API, you can still configure that producer using your secrets and config maps that are stored inside in your cluster. So this provides a way to centralize the sensitive data, such as your credentials and your certificates and so on, in Kubernetes native resources. And that provides all the functionality that Kubernetes provides there in terms of RBAC controls and encryption to keep your secrets safe. This also provides then for dynamic configuration updates. So when you want to make a change to your configuration, you can make the change, and that'll be automatically reflected then into the Kafka components without the need to do any restarts. So when using the Kubernetes Config Provider, then you're protecting your Kafka components during the process of changing configuration without any need for any restarts.
So next one, finally, let's talk about observability and testing. So the problem that we have in this case is that our SRE teams wants to know what's happening on the cluster. So they need some monitoring solution in order to get, of course, metrics out from your Kafka cluster, having some dashboard, like Grafana dashboard, in order to visualize all these metrics and so on. On the other side, something which is not actually used directly within your Kafka cluster, it's about Kafka developers, or for example, Strimzi maintainers, contributors, going and testing their applications while they don't want to run a real Kafka cluster. So developing unit and integration tests for a new feature, for bug fixes, or just testing the Kafka clients and so on. This is another problem that you can have. So starting from here, finally, we are going to add the two last components. On one side, we have the metrics reporter that, as you can see here, is running both on the Kafka cluster and even on HTTP Bridge in order to expose metrics to Prometheus. And we will see how it works in a few. And on the other side, as I already mentioned, the test container component, it's more not really part of your Kafka cluster, but something that you can use in order to test the features, the bugs, and all the Kafka applications that you want to, so that you are developing. Let's start with the Strimzi metrics reporter. So for people who knows Kafka, they know that Kafka is exporting metrics in the GEMX format. And Strimzi provides a component which is the GEMX exporter, or actually I should say use the GEMX exporter, running as an agent alongside the broker in order to get these metrics from GEMX and then translating them in Prometheus. And it's exposing these metrics on an HTTP endpoint so that a Prometheus server can go and scrape these metrics. Of course, there is some translation happening here. The GEMX exporter has a kind of configuration files where you can define what are the metrics that you want to get from Kafka, if you want to do some relabeling, if you want to change some metrics names, and so on. And of course, it can take time. Sometimes if you are exporting a lot of metrics, because there is this translation in the middle from JMX to Prometheus. Because most of the systems these days are using Prometheus as a kind of format to have everything on Grafana dashboard. And with the Strimzi metrics reporter, it's a plugin that is plugged directly into Kafka. It means that it's configured as one of the metrics reporter that you can have in Kafka. And it just reads the metrics directly from Kafka and exposing them directly in Prometheus without any kind of translation. For this reason, so it can be used even if you are not using Strimzi, but just Kafka on your bare metal or virtual machine. So these components, anyway, expose the metrics the same way, so with an HTTP endpoint, where the Prometheus server can go and scrape, and also provides a way for filtering the metrics. There are some configuration in the allow list where you can say what are the metrics that I want to expose. Of course, everything is configured within your Kafka, Strimzi Kafka-related custom resource. The last component is the Strimzi test container. As I already mentioned, if you are a Kafka developer, if you are a Strimzi contributor or a maintainer, you want sometimes to test some features, new features, or bug fixes. So you need to run some unit and integration test. And instead of running a real Kafka cluster, you can use these Strimzi test containers framework, which is based on the test container framework, providing images for running Kafka on container in several configurations. So you can set up the number of nodes. Of course, you can set up if the node are going to be, because today is just Craft support. In the last versions, there is not Zookeeper anymore. If you want to use a combined node with controller and broker rule, or if you want just controller and then other nodes to have brokers rule, and so on. And you can also configure the Kafka versions that you want to use, and then running your unit integration test against it. This is, for example, what we use every day in Strimzi in order to run our pipelines. And also, the Kafka Connect support is within the Strimzi test container. So you can even spin up a Kafka Connect container if you have some connectors or things like that that you want to test. And with that, we pretty covered the entire full Strimzi ecosystem. So as I mentioned at the beginning, Strimzi is not just the operators. We have the operators for sure for all the cluster management that we need, but across the session, we see that the ecosystem is full of other components coming from the community. So we solved several problems. We started from the connection with HTTP and MQTT, so having MQTT producer sending the message, HTTP client using the Kafka cluster, or even simplifying the Kafka client's configuration by using the access operator. On the other side, we introduced the OAuth library for allowing a token-based authentication for our clients, the quotas plugin for throttling the clients, and then even something more about the configuration to allow a more dynamic configuration within your Kafka cluster by using the Kube Config Provider in a Kubernetes native way. And on the other side, the drain cleaner to avoid to lose your high availability in your cluster and to give the Strimzi operator a way to move the pods, but having still the cluster working when there is some node eviction happening in your Kubernetes cluster. And finally, we mentioned the metrics reporter for exposing the metrics and the test container for the unit and integration test. So remember, if you are using Strimzi, you can complete your solution by looking at all these several components. They are all under the Strimzi organization in GitHub, so you can go and find, of course, all the source code there and contribute if you want. With that, this is a way for joining us, joining the Strimzi community. And there are several ways to engage with the community, starting from even easy fix with the documentation, or reporting issues, reporting bugs, or even fixing the things that you find, opening pull requests, or asking for new enhancements like providing Strimzi proposal that we can discuss in the community together with all the other maintainers. So it will be great to if you are already a Strimzi user, to have you engaged with us to improve this project. And with that, these are all the links that you have to go and look at Strimzi. So the official website, the GitHub repo, as I said, where all the components live, the Twitter and the LinkedIn account in order to get the news about the releases or what's happening in the community, and even the YouTube channel where we publish demo videos, our community meeting that we have every 2 weeks online. And with that, yep, thank you very much.